All right, so for this one, the first thing to look for is I would probably start with this first problem here, the x minus a squared over x minus b. If the degree in the numerator is higher, it's not going to be a horizontal asymptote, right? So I'm looking for who doesn't have a horizontal asymptote. This guy looks, these aren't the best graphs. This guy looks like he's going that way, and this guy is going that way. So I'm going to have to mark him with a 3. Um, what's next? How about this would be kind of an easier one, I think. If you think about it, without all the rational function rules, asymptotes, and things like that, if you just look at what's going on in the numerator and the denominator, since they're both squared, sure, we could do, okay, they have the same degree, and then see what happens with the horizontal asymptote. But in this case, what gives this away, since they're both squared, that means all your outputs will be positive. Right? That means for any input x, whatever it is, whether it's negative or positive, and I take away a, that could be negative or positive. But as soon as I square it, it's positive. Same thing in the bottom. So that means all my outputs are positive, which means it's got to be, this is the only guy with all positive. The range is y greater than or equal to 0. So that's got to be my 2. And then this one, I could pick this one off. The degree of the denominator is greater. That means I have to have a horizontal asymptote of 0. So we took care of 2 and 3, so they're out. These graphs are a little crowded, right? So who's got a horizontal asymptote of 0? It looks like 1 does. This guy looks like he's going to go down to 0. It's hard to tell there, but this one definitely does not have a horizontal asymptote of 0. So 1 looks like it has horizontal asymptote y equals 0. So that leaves us with 4, but why would this one, x minus a over x minus b, be 4? Well, remember, if they have the same degree, then the horizontal asymptote has to be, the coefficient of the ratio of the leading coefficient. So that's got to be the line y equals 1, that horizontal asymptote there.